Hi, I'm Miss Thorson. I'm a middle school science teacher, and today is May 4th, 2020, which means today is Star Wars Day, because in Star Wars they say, "May the Force be with you," and of course, May the Fourths sounds like May the 4th, and Star Wars nerds will look for any excuse to celebrate Star Wars. But what I want to talk about is what is force. Of course, in Star Wars, force is the thing that holds the universe together. It has a dark side and a light side. In physics, force is mass times acceleration. And you might know that as Newton's second law. Force equals mass times acceleration. But what does it mean? It means that the amount of force that something has, the amount of impact it has if it hits you, is the result of how quickly it's changing speed and how much mass it has. So we have a pirate ship here. I know, it's a beautiful model. It's obviously built to scale, but she does swim. So we're going to take a look at how force and mass work together to create acceleration. And to do that, I have our old friend, the spring scale, which measures force through the use of a spring. And force, remember, is measured in newtons, like Sir Isaac Newton, like Newton's laws of motion. So we are going to hook this up hook up our boat to our spring scale to see how much force the boat exerts when we change the speed of the fan.
Clarification. The fan is not acceleration. The fan is the cause of acceleration, or change in velocity, just like gravity is the cause of acceleration when you fall. Keep that in mind as you watch the video.
And I have a really exciting, very high quality stand for my phone so we can get some close-up shots of what's happening with the spring mounts. So first, for proof of concept, before we actually start measuring, I want to show you that this boat does, in fact, float or roll. So I'm just going to turn the fan on. I'm just going to turn the fan on low. It takes a little bit for the fan blades to get up to full speed. But you can see that this fan does, in fact, make this boat move. Okay, so we have the ship hooked up to our spring scale here, and you can see it's loose right now. So on the spring scale, and I'm recording up here, on the spring scale or the spring balance, you can see that it is at 0 newtons, meaning that right now there is no force being exerted on the scale. So I'm going to hold the scale still so the scale doesn't move, and I'm going to turn the fan on low to start with, and we'll see if that causes the ship to exert some force. So we can see that our ship is starting to move. It's not going anywhere because I'm holding it with this spring scale, but it is exerting a force. You can see here it's gone down to between 0.1 and 0.2 newtons. So if this is 0.5 right here, that means each of these little lines is 0.1. So we're down between 0.1 and 0.2 newtons. And the fan is about as fast as it's going to get on low. So I'm going to turn it onto medium, and let's see if increasing the acceleration, increasing the amount of wind, increases our force. Okay, and so you can see now that we're now getting down between 0.2 and 0.3 newtons of force on our spring scale. Now, I'm going to turn it up to high. The most likely outcome is that you can see we're wiggling a lot. The most likely outcome is that our ship, not me, the ship is going to lose its balance, and then it's going to fall over and throw coins everywhere. So we're probably going to shipwreck, but if not, we might even see the newtons go up a little bit more on the spring balance. So let's Okay, so what's happening is because it is so unbalanced, as it's bouncing back and forth, it's sort of losing some traction. So you see there are times when it's going here on the scale, it's going down even further than that 0.3. It's going down closer to 0.4. But because the wheels are not staying on the table, because it's rocking back and forth so much, it's not able to exert the same force. It's not able to get a grip. So this is the same thing that would happen when you try and speed your car out of a mud puddle. Sometimes your wheels just spin. That's kind of the equivalent here. So I'm going to turn the fan off. If you watch the spring scale, you'll see that the spring scale is now going back to 0. So it is no longer exerting force. There's a tiny bit here. So there's a tiny bit here of force. It's less than 0.1 newtons. And the reason that is there is because there's enough friction between the wheels and the table, or the paper in this case, that the ship can't roll backwards to 0 force. So there is a tiny bit of force here. That's the result of the friction between the wheels and the table. But that's it. So that is force equals mass, in this case the weight of the ship, times acceleration, which in this case is the fan. And when we turned up the acceleration, the fan, we got more force on our spring scale. Happy Star Wars Day. Have a great day and be well. And I don't know, tell me what you want to see next. Bye.